Welcome back to the continuation in our series, Getting to Know Cimatron Die Design. This video will focus on strip design, so we encourage you to see the previous video on forming and bending as well. Topics we will discuss today include nesting, identifying punches, developing a carrier, and then analyzing die forces. We will begin by selecting nesting from among the strip design tools. Nesting will allow us to create two different parts in the strip. From here we simply pick the blank that we've developed in our forming and bending. All throughout we will keep track of our net utilization and our total scrap area. In this case we're working with a single part or one blank, but we can select if we want this die to be a 1 out or a 2 out. Likewise it could also be a left hand right hand. Here we have rotated a second row and we're making adjustments to the progression and the overall strip size. By adjusting the shift, we can force the parts to nest in a tighter pattern, and this will increase our net utilization. At this point, we'll make the decision that this die will be a 1 out die, and we will adjust the progression accordingly. One of the most powerful features about nesting is that it can be edited at any time during strip development. This takes us now to strip dimension. There are a number of things that we will do here inside a strip dimension. We'll decide on which way we're going to develop the strip, left to right, right to left. We're going to decide how many stations will be in this progression, how many of those stations will be forming stations, or how many will be trim punches. And like before, anything we do here we can edit later, anytime during the strip development. We will also make the determination on the overall strip width, as well as margins or distance of material that will be outside the blank. There's also a start margin, so that we have an area of space where we can put the pilot. So here we will increase the start margin so that we have room for the first pilot hole, as well as other punches. So we will now jump into carrier sketch, where we will define the carrier as well as the punch boundaries. The Sketcher toolbar is now available for use. Throughout the course of this, you'll see that we're not worried about everything being exactly perfect. We want to get the general outlines of the carrier, the width, punch location, things like that, pilot location, and then a rough outline of each of the different punches is suitable. So first we reference the blanks, and then from there, drawing up a rectangle to represent where a punch may extend out past the edge of the strip. Also, we will simply use a line to show where two punches would theoretically meet, even though in actual fact we'll design an overlap, plus some simple dimensions to control the sketch in general. We have now drawn in the carrier, and next the pilot. Throughout this, I am deliberately not trimming up the sketch, but using a rough sketch to show the power of Cimatron's strip design in creating punches. We will now use punch and start with some of the simple holes. So first we will select the pilot punch. It now displays the punch across the progressions. We simply pick where we want that punch to occur, and then it carries the holes down the strip. We would go on to repeat this method with all of the similar simple punches, such as the simple wire EDM punches and also the round hole punches that would be made with a catalog punch. We will now develop the more complicated punches, and to do that we will use punch trim curve. Here we simply pick in the regions of the punch and it snaps the outer boundary around just like a rubber band. We also have the option of putting round corners on the contour of the punch. And here you can see the time savings because the sketch does not need to be perfect. We will now create the punch overlap by using the cookie function. We will pick the line segment of the punch where we wish to have the overlap. Here you see the advanced option, which will create a notch where two punches would overlap. We will change that to extend, increase the offset value, and also increase the radius on the corners so that we can get the overlap we desire. Now we will go back to punch and pick this new contour. We pick the station where the punch occurs and it carries the cut down the line. This leaves our last punch. We will again use punch trim curve and pick that region of the punch with a single indication. Then we add rounds on the corners. And then finally, we will go back to punch and then pick the station where that punch will occur. We will now go to forming shapes and add the forms that we had created previously. We simply pick the form from above and then indicate where we want that to go on the strip. As we continue this process with the other forms, you can truly see the strip taking shape. And the speediness with which a strip can be put together in Cimatron die design truly makes it a valuable resource. At any point, the designer may make the choice to add an idle station. Like we said before, we can always go back into nesting and strip dimension and make changes. In this case, we will go into strip dimension and add another station. Also, if ever the original form is reworked, then the strip can easily be updated. Again, using forming shapes, we will relocate the last station and then add the form that we wish to have in the idle. And with that, we have a finished strip. The last subject in our video today is die forces. Every trimming punch and every forming station has the force displayed in either pound force or in tons. Also, the die tip point is displayed on screen with a red-yellow dot. Also, if pressure pads were used in any of the blanking operations, the force of those pads would be displayed here as well. All this information can be exported to a CSV file. Thank you for reviewing this presentation. Please look for our next video in this series on the subject of die set and setup file.